lesson, you will analyze the characteristics of graphs of quadratic functions and we'll be able to graph some quadratic functions. So what is a quadratic function? It is an equation in the form y equals ax squared plus bx plus c where x is not 0. So you're going to notice it has that power of 2, which means that the graph is going to be a parabola. A parabola is a graph of a quadratic function. They're going to have a minimum, which is the lowest point on the graph of a curve. If that parabola is going like this, then we will have a minimum because it has a lowest point right here. We will have a maximum, which is the highest point on the graph of that curve. If it is going like this, well then we have a maximum right here, which is the highest point. In either of these graphs, we have what's called a vertex, which is the maximum or minimum point of a parabola. So this is the vertex of this graph, this is the vertex of this graph. Standard form of a quadratic function is f of x as ax squared plus bx plus c, where a is not equal to 0. So standard form is having that power of 2, power of 1, and then a constant. So this is a quadratic function, and this is known as standard form, power of 2, power of 1, and a constant. The graph is called a parabola. And how do we know if that parabola is going u or up or down? Well, this is what tells us. If you look in front, this is a negative a. So that means this graph is going to be going down. And think of it like a frown, negative, sad. It's going down. This graph is a positive a. So this graph is going to be going up. This is a U shape. And think of it as positive because this is a positive a. So the sign in front is actually going to determine whether it's going to be uphill or downhill, or have a maximum or minimum. So if we were going to graph this, what we would have to do in the past is plug in a bunch of different x values, like try -2, -1, 0, 1, and 2, and see what's happening as we plug these in. -2 squared times 3, 6 times -2, so on and so forth. Well, I have an easier way, and this is what we're going to do to graph. I'm going to show you two different things you could use. The first thing that I'm going to show you is a graphing calculator on HRW. You type in your quadratic function, 3x squared plus 6x minus 4. You click on graph, and then you get the parabola here. What's really cool is I have a table of values right here, and it gives me all of the coordinates that I could then graph on my paper. Something else that's really cool is you click on trace and you can use these arrows and you can clearly see that it has a minimum of -1, -7. Down here is where it tells you that point that is your minimum. So you can see everything here that you need for the graph. Your domain is going to be all of the x values that you could have. And if you would look here, I have all x values represented. I can go anywhere on this x-axis and have a possible coordinate, so my domain would be all real numbers. But my range is going to be a little more restrictive. If you will notice here, I do not have any y values below this -7 point right here. So we're going to say y when it's greater than or equal to -7 is our range, because we have y values greater than -7 all the way up here. So this is the domain and range of this function. If you don't really like this graphing calculator, you can use Desmos. And you could click right here to see what that minimum is. The Desmos, you can scroll in and out. You can make a table of values over here. So you can still have everything on Desmos that you have on the graphing calculator. You can still see that we have a domain of all reals, a range of greater than -7. You just choose which of the two you would like to use. All right, so you graph the example in your notes. Now we're going to talk about axis of symmetry, which is the vertical line containing the vertex of a parabola. If you will look at this parabola, this has an axis of symmetry, which is the y-axis. Look, this is a fold line. This is a symmetrical line that has half the parabola on the right, which is the same as half the parabola on the left. And if you'll notice, origin is the minimum or vertex, and that is right on this line. There is a formula for the axis of symmetry. X equals -b over 2a. Now remember, we have a, which is in front of your squared, and we have b, which is in front of your power of 1. So let's use the axis of symmetry. A here is 2, b here is 4. So if I plug those values in, x is equal to negative b over 2a. Let's simplify. X is equal to negative 4 over 4. Let's simplify. X is equal to negative 1. Now that we have this simplified down, we know that the line, if I have a coordinate grid here, if this is negative 1 on the x, I know that my vertex is somewhere on this line. This is the axis of symmetry. Well, we can find the vertex if we plug this x in. Watch. Y is equal to 2 times negative 1 squared plus 4 times negative 1 minus 3. Look what I did. I just plugged that negative 1 for x in for every x in my equation. Now we'll simplify it. Order of operations, we have to do the power first. So this would be 2 times 1 plus 4 times negative 1 minus 3. So that's going to be 2 minus 4 minus 3. 2 minus 4 is negative 2 minus 3. So y is equal to negative 5. Guess what we have now? This is a coordinate. Negative 1, negative 5 is the vertex of this graph, or the lowest point, because this is a u that's going uphill because it's positive. So I would go down 5, and this is going to be, I know, my lowest point. What is the y-intercept? Where would this cross the y-axis? If you will remember, the y-intercept is when x is going to be 0. So we plug in 0. 2 times 0 squared plus 4 times 0 minus 3. That's going to be 0 plus 0 minus 3. So we get a y of negative 3 when we plug in a 0. So that's negative 3 right here. So we know this is one of our coordinates. So we almost have half the parabola just from these values. We can really use an axis of symmetry to even help us graph. So if you wanted to check this line, you can plug it in, check this parabola, plug it in and see if you get the same vertex, negative 1, negative 5, and the same y-intercept where it crosses the y-axis. Try that in your notes first and then try the example. Now let's try another, finding the axis of symmetry. A is negative 1, B is 6. Do you see how that's a negative 1? So when we plug this in, we get x is equal to negative 6 over 2 times negative 1, which is negative 6 over negative 2, which is x equals positive 3. If our vertex is 3, we can plug in that 3 for our axis of symmetry. We can plug in that 3 to find what our vertex coordinate would be. So we have negative 3 squared plus 6 times 3 plus 4. So we have, this would be a negative 9 plus 18 plus 4. That would be 9 plus 4, which is 13. Now to find what our intercept is, that's 0 plus 0 plus 4. So 0, 4 is your intercept where it crosses the y-axis. So you try the example in your notes. Does this function have a minimum or a maximum? This is going to tell you. You should say that this is going to have, because this is going to be going downhill, that this has a maximum. Remember, it would be a minimum if this is positive. It's a maximum if this is negative. So I know that this is maximum, so I'm able to kind of sketch what this is. You could then still plug it in using your graphing calculator to find exactly what the domain and range would be. The domain is always going to be all reals every time. You're going to have your domain be any values of x. Your range is going to change based on whether it's a minimum or a maximum. So when you plug this into your calculator, you will see that this is negative 2x squared minus 4x plus 6. Sorry that took so long there. We knew it was going downhill, but now you can clearly see that this point, this highest point here, is at -1, 8, so it goes up 8 high. So your range is going to be all your y values that are less than or equal to 8. 8 is your highest point. Now you try the example in your notes of finding if it's a maximum or minimum and your domain. So with graphing, you want to find the axis of symmetry. From there you can find the vertex and the minimum or maximum and find the y-intercept. You can use symmetry to graph and make sure you have a smooth curve, or you can check with your graphing calculator. This is a very nice table that is in your book on page 547 that shows you the difference between linear functions, exponential functions, and quadratic functions. And this is what we're working with now, is the parabola. We've already dealt with the curve and the line from other chapters. All right.